So right now, these are rectangular graphs. And they're rectangular in that they have x, y. What we want to turn them into is into polar graphs, where they have r and theta. Okay? So, the first graph, x equals 2y. Anybody describe for me what that looks like? Starts with an L, rhymes with ein. Line, very good. And if I were to divide by 2, I get y is equal to 1/2 x. Everybody agree that that is a line that has a slope of 1/2? Now, I want you to think about that for a second here, okay? I want you to think about that for a second here, okay? If we were to graph that line, it would look something like that, wouldn't it? Does the angle of the line change? No. Theta is always the same, isn't it? Theta is always the same. Does the distance from the center change as the line continues along? Yeah, so r changes, but theta is always the same. Get it? Okay, so in order to convert this, all we're going to do is plug in a value. Yesterday you learned that instead of x, what could we put in its place? If we're converting from rectangular to polar. Very good. X was equal to r cosine of theta. Again, you get your own notes for this test, so please make sure that you figure out which notes you want to put down. I told you that the stuff that we put down up there would be very important to you. So x equals r cosine of theta, and y is equal to r sine of theta. Okay? And so I'm going to put r cosine of theta in for x equals 2 times r sine of theta in for y. Now, normally we try to get r equals. We try to get r equals. But in this case, you told me that theta doesn't change. Theta is constant, isn't it? So we're actually going to come up with a constant theta value. And notice how the r's will disappear. I divide both sides by r, and what happens to the r? They are gone. And so you get cosine of theta is equal to 2 sine of theta. Again, you told me that theta is the same the entire time. I want to solve for theta. Anybody think of what I could do to solve for theta? Sure, divide by cosine. And so if I divide by cosine, I get 1 is equal to what? Close. 2 tangent of theta. Again, I want to solve for theta. What should I do to both sides? So 1/2 is equal to the tangent of theta. And what could I do then to find theta? Inverse tangent. So as I turn my calculator, on, I'm going to tangent inverse, and I got 0.5, and I get 26.56 degrees. I want you to think about that for a second. Does it seem like that angle might be about 26.56 degrees? Yeah, exactly. Now, what they want is, so theta is equal to 25, is it 25? 26.57 degrees. They actually want the answer in radians. They do. So do you remember what we do to convert an angle from degrees into radians? The mathematicians of the world that prescribe polar coordinates. Huh? I agree. Let's cancel them. Yeah, they don't get their ideas. They conform to our ideas. We get to protest, but when they do, we'll shut them up. Yeah. Cancel, cancel, cancel. Oh, sorry, YouTube Nation. This is actually 6 hours. You're going to be watching this. You're going to be watching this now. You're going to be wondering, what's going on? They want to cancel some of the mathematicians of the world, which kind of hurts my heart because I kind of feel like I'm part of that group. But maybe I'll jump. Maybe I'm a spy. I'm a spy. I kind of try to blend in with the math group, but really, I'm just part of the students. Anarchy. Let's go. Okay. What's that, Kaylee? What do I need to do? Blog?
Blog.
What's blog?
Like, you know your life. Like, that's like,
Okay, hold on 6 hour right now. So they would like me to vlog my life. And when I said, what is vlogging? Ava Jensen said, yo, bro. Like, no. Okay. Let's go back to the math. We multiply by pi and we divide by 180. That's how we convert from degrees into radians. So theta is equal to 0.46. Now I want you to think about this for a second here so that we can make sense of what's going on. So this angle is 0.46 radians, okay? Watch how this works. If I look at the coordinate 1.46, notice how I rotate 0.46 and I go 1 unit in that direction. That ends up on the line, doesn't it? Yeah. And if you have 2.46, well then you just turn 0.46, you go 2 units. And if you had negative 3.46, you would turn 0.46, you go 3 units in the opposite direction. So you can see that no matter what the R value is, as long as theta is the same, you end up on that place, okay? So this is an example where theta stays the same. Now, as you look at the next example, who can tell me theta equals 0.46? Who can tell me what shape this makes? It is an ellipse. It's a special kind of ellipse. It makes a circle. The radius is 5. Very good. So, everybody agree this is a circle with a radius 5? And if you look at your, I'm going to turn this on and go into y equals. Notice you can't type in x squared and y squared. Like you couldn't graph this on your calculator. We're going to show you how that happens now. It's kind of cool here. Instead of x, what am I going to put in that place? R cosine of theta, and I will square that, plus r sine of theta, and I'm going to square that, is equal to 25. Okay, so I'm going to square both of these. I get r squared times cosine squared of theta plus r squared times sine squared of theta is equal to 25. Get to square each piece. Anybody see something I can do to solve for r here? Take out r squared. Isn't it the case that when you factor out the r squared, you're left with sine squared plus cosine squared? And what is sine squared plus cosine squared? It is 1. What's that? So we get r squared is equal to 25. Now, pause. Think about a circle, folks. And as we think about a circle, does the radius ever change? No. Does the angle change? Yeah, it does. The angle changes as you go around, but the r value never changes. And so you come up with r is equal to what? 5. Now, we can plug that into our calculator and actually come up with the graph of the circle. It's pretty cool. Take out your calculator. And as you type in y equals, you can see this piece. And what we're going to do is we're going to show you the polar expression of your graphs. So if I press mode, first of all, polar always wants to be in radians. Please make sure you're in radians. And then instead of function, I move over to polar. And now if you press y equals, you can see that this is what we have. So I'm going to put in just 5. Okay? the other thing I'm going to do, and this is a little bit different, but I'm going to go to my window, and your window is very different at this time, okay? See that? So just to make sure we're all on the same page, I'm going to go zoom 6, and hopefully it'll bring me to that right spot, but it does look like an oval because our screen is longer than it is tall, isn't it? And so if you actually zoom as a square, notice how it creates a perfect circle for you. Now, here, I did zoom 4 to get a circle. Now, I want you to look at this real quick. Is this a function? Does it pass the vertical line test? No, it's not a function of x and y, but it is a function of r and theta. So we can represent functions in multiple ways, and we can end up coming up with some interesting things. It allows us to work with a lot of real-life situations that are otherwise very complicated to work with. But I always think that that's pretty cool. Okay, we'll do the last one here. This is nice and easy. Can somebody tell me, what does the graph of x equals -2 look like? Yeah, it is a vertical line. R is 5. Yep. R is 5 is the answer. Now, as I draw a line, a vertical line that goes through -2, as I draw a vertical line that goes through -2, I want you to think about this. If I pick a point here, okay, notice how I have the theta value would be what? 180 degrees or pi, right? And then the r value would be just 2 units. But if I move to a different spot here, did the theta value stay the same or did it change? Did the r value stay the same or change? I think that that's longer than that, don't you? And if I pick a spot here, do you agree that r and theta both changed again? So r and theta are both changing in this one. In the first two, theta stayed the same and r stayed the same. But here, they're different. For x, I'm going to substitute what? R cosine of theta is equal to -2. I would like to solve for r. What am I going to do to both sides? I get r is equal to -2 over cosine of theta. And I will accept that as an answer on your test. Can somebody think of another way to write that? Very good. -2 secant of theta. 1 over cosine is the same as secant. Now, watch what happens here if I go into y equals. I'm going to type in -2 divided by cosine of theta. Okay? I have that typed in, and as I press graph, it creates a vertical line. A vertical line that we couldn't graph before. So again, polar coordinates give you a lot of graphing options that you otherwise would not have. I went into y equals, which is r equals, and I typed in -2 divided by cosine of theta. It is crazy. Can I show you something crazier? Okay, I'll show you again, folks. So I'm going to do 10 times the cosine of 5 theta, and it's just the xt. This is just your variable button, and as I press graph, so this is something that's kind of neat. It turns out that between parametric equations and polar equations, you can create a graph of absolutely any picture you want to see. And I had a student one time, big Batman fan, and he went and found an equation for the Batman symbol. And it took him about an hour and 10 minutes, but he plugged it into his calculator, and he made a graph that was the perfect image of the Batman symbol. You can come up with any graph that you want.
That should be our final.
Your final exam? She wants an hour and 10-minute final exam on typing in the Batman symbol. Accepted. Let's go. If you get the formula for it. What if you type it in incorrectly? Then you fail. Okay. There you go. Take out your worksheet. It's time